Today I talked about trig substitution integration, and I used some tables in it, so we'll get some more work with tables. Now, I'm going to work 4 problems, but first I want to give you what's really going on with trig sub. Someone cleverly noticed a long time ago that if you have a right triangle and you call that theta, and that's the right angle, and if you put, let's say at x here and a here, you get a square root from the Pythagorean theorem of x squared plus a squared. If you have a right triangle and you put, let's say x here and a here, then this side becomes the hypotenuse squared minus the leg squared. If, however, you have a right triangle and you put, let's see, where else could we put x? We put it on a leg and we put it on the hypotenuse. What if we, let's see, put it the x, so let's say here and a there, then we get the square root of a squared minus x squared. So we can get x squared plus a squared, or a squared plus x squared, that doesn't matter. Or you can get x squared minus a squared, or you can get a squared minus x squared. Now, these three are useful in integrating expressions that have x squared plus a squared, or x squared minus a squared, or a squared minus x squared. And they all work a little bit different. So you need to watch each one of these. Now, if I just look at the simplest relationship, forget that thing, then I have the opposite side and the adjacent side, and so the tangent of the angle is opposite over the adjacent. Or I can multiply both sides by a and get a tangent theta equals x. So when I have a x squared plus a squared, I'm probably going to use a tangent theta as a substitution for in it. And I'll explain that in just a second. If I have this, the simplest relationship is between the adjacent and the hypotenuse. A over x would be the cosine, but I want x in the numerator, so x over a is the reciprocal of cosine, which is secant of theta is x over a, or if you will, a secant theta equals x. In this one, the simplest relationship here might be the sine of theta is x over a, or a sine theta equals x. Now, we could have switched these two, and then we would have had cotangent equals x over a. If we would have switched these two, then we would have had, switched these two, then we would have had cosecant is x over a. And if we would have switched, let's see here, these two, we would have had cosine of theta equals x over a. Derivative of cosine or cosecant or cotangent all produce a negative, So generally we use these instead of the others, because we are going to be taking derivatives. Now I'll show you what I mean. So this is the first thing you need to recognize. Do we have something squared plus something squared, a variable squared minus something squared, or something squared minus a variable squared? So now I'm going to put up 3 problems in no particular order that I used in class. Actually, I'm going to put up 4. And I'm going to write them all right down here, and then we're going to kind of match them up. So I have 1 is 4 over square root of 9x squared plus 25, that whole square root cubed dx. Next one is going to be the antiderivative, the integral of 2 over 16 minus x squared quantity squared dx. The next one I'm going to put up is 1 over x squared times the square root of 25x squared minus 16 dx. You notice I'm using 9, 16, and 25 a lot, just because they make nice numbers. I've used something not so nice. And the last one I'm putting up is 1 over x squared times the square root of 25x squared plus 16 dx. So, let's look at each of these. This has a square root, and it's a variable squared times a number, but still, a variable squared plus 25. So which one of these looks like most like that? And I would say this one. So this one I'm going to use a tangent trig substitution. This one has a constant minus a variable. There, you could think of 4 squared minus x squared, so it's a squared minus x squared. Well, that's not this one, that's not this one, that's most like that one. So this one would be a sine theta substitution. This one, I have 5x quantity squared minus 16, so I got a variable squared minus 4 squared. Variable squared minus 4. That's a secant substitution. Excuse me. And this one, it's a plus again, and so it's a tangent substitution. Okay. So now let's go through these. Now, these look so similar, and yet they are so much different when we're doing them. Okay, so let's do this first one. Okay, the 4 in the numerator is just a constant. It can be pulled out. So it's going to be 4 antiderivative of 1 over 9x squared plus 25, the square root of that denominator cubed. And we're going to do a tangent. So I'm going to set up a triangle. And these triangles are really important to get the correct answer for these. And I'm using the tangent and I want to get this, and that shows up on the hypotenuse. So I want the hypotenuse to be 9x squared plus 25. And I want the variable on this side opposite it. So I'm going to put not just x, but 3x, because then 3x squared is 9x squared. 3x quantity squared is 9x squared. And I'm going to put 5 here, which would make the 25. So I get that squared minus that plus that squared will equal the hypotenuse squared if I take the square root. So, what is the tangent of theta? Well, it's 3x over 5. So, what will I get if I take the derivative? Because I'm going to start replacing things and talk in terms of theta, so I need to replace the dx. So I need to take the derivative here. The derivative of tangent of something is secant squared of that something times the variable is theta, so I'm going to go d theta, equals, and the derivative of this is simply 3/5 dx. So if I multiply both sides by 5/3, I'd have something to replace the x with. Now, do I have something to replace the square root with? Well, I can use a trig function that relates these two sides or these two sides. And I'm going to choose these two sides. And so to get that in the numerator, that's going to be secant. Secant is the reciprocal cosine. Cosine would be 5 over this, so secant's that over 5. So the secant of theta is square root of 9x squared plus 25 over 5. Okay, so now I've got the information I need to start making some replacements. So 4, antiderivative, 1, denominator. Well, that's square root. If I multiply by a 5 on both sides, 5 secant theta is equal to that square root. So I'd have 5 secant theta, but that square root is cubed, so I have to cube this. And so I've replaced the denominator, I've pulled the 4 out, the dx needs to be replaced. And the dx is going to be, if I solve for dx, it's going to be 5 over 3 secant squared. So I'm going to write 5 over 3 secant squared theta d theta. This is my dx. This is that denominator. And there's the 4. So now, let's clean this up. Looks like this is 4 antiderivative. This is cubed, so this is 5 cubed secant cubed theta. And then I have a 5 in the numerator and a 3 in the denominator, which I could pull out. I could have pulled the 5 out, but I'm just going to cancel one of the 5s there, so I left it there. And I have secant squared theta d theta. So this 5 will make it 5 squared. So I'll have 4 over 3 times 25, which is 75. Antiderivative. And this secant squared will leave just a secant in the denominator. But that's, well, I don't remember getting that constant, so I'm going to have to check my arithmetic here in a sec. Antiderivative of cosine theta d theta, and yep, I think I'm all right here. And the antiderivative of cosine we know is sine, so we have 4 over 75 sine of theta plus c. Now we go back and look at our triangle. Remember, this is all for one problem here. I'm not using these other ones yet. The sine of this angle is opposite over hypotenuse, so it should be 4 over 75. Sine is 3x, move it up here so you can see it, 3x over the square root of 9x squared plus 25 plus c. So if I took the derivative of this, I should get something that looks like 4 over the square root of 9x squared plus 25 cubed. I'm going to attempt to do this one just to check it. So now I'm going to take the derivative. So the 4 over 75, that's times this, will hang around. This is a quotient. The derivative is a quotient, is the derivative of the numerator times the denominator minus the derivative of the denominator, so that's this to the 1/2, so I would get 1/2 this to the negative 1/2, which would put it in the denominator, times the derivative of the inside, which is 18x so that's the derivative of the denominator, times the numerator, all over the denominator squared. And so that would get rid of the square root. And the derivative of the constant is 0. Now, if I try to get a common denominator in this numerator, I'd have to multiply by a 2 in the numerator and denominator, and by the square root of 9x squared plus 25 in the numerator and the denominator. And so I would have the common denominator. Actually, I don't need to multiply by 2 because this 2 will go into the 18 and make 9. So I can cancel the 2's. Don't have a 2 here. So let's see what, bring that up. So I'm going to have 4 over 75. There's a 3 in front of here. There's a 3 in front of that, so I can bring out a 3. And I'm going to have that numerator squared, which is 9x squared plus 25, minus, I pulled out the 3's, and so I have 9x squared that's all over the square root of 9x squared plus 25, and that's all over 9x squared plus 25. So these 9x squareds cancel. So the 3 and the 25 will cancel the 75, and so I will have 4, and then I will have, I can bring this over 1 up times that, so get this right here. I will get 4 times 9x squared plus 25 divided by the square root of 9x squared plus 25, and this is, if I put the square root on this and then square it, this will cancel one of those, and I get 4 times the square root of 9x squared plus 25, which is not right. Should have been in the denominator. Here, let me see here. I got this fraction over this one, so I have to multiply by the reciprocal. So I should have multiplied by 1 over, oh, yes, I should have multiplied by 1 over, bad mistake, 1 over 9x squared plus 25, which is the square root squared times the square root is the square root cubed. Forgot I was going for the cube. So that is correct. So I got the right answer. Okay. Now, keeping these there, keeping that information there, let's look at the second one. Now I have a 16 minus x squared, so that's a constant like 4 squared minus x squared, which is looking like this one. So I'm going to make a sine substitution, as we said. And the sine substitution, so I'll make my triangle. It's always important to make the triangle. And I want to do a sine substitution, and so I'm going to put my, what would be the x. In this case, it's just x. It's not like 3x or 5x. So I'm going to put x on the opposite, and on the hypotenuse, I'm putting the 4. See how that works with the sine substitution? And so this side becomes the hypotenuse squared minus the leg squared. And there's the angle, and so the sine of the angle is x over 4, or if you will, 4 sine theta will equal x. I'll need the derivative, so 4 cosine theta d theta will equal dx. And I need this square root thing, which I could go with that one, but I'm going to go with that one. So it's going to be the square root of 16 minus x squared, adjacent over the hypotenuse, is the cosine of the angle. So now looking at my integral, that was 2, which I can pull out, over 16 minus x squared squared dx will become 2 antiderivative. Well, if I put the 4 over here, multiply both sides by 4, 16 minus x squared, the square root of, move the 4 over to here, 16 minus x squared square root would have to be squared to make the inside, and then it's squared again. So if I square both sides once, I'll get 4 cosine of theta squared, and then have to square it again. I'm going to get 4 to the 4th cosine of theta to the 4th. So that's the expression for this denominator. And then the 1's in the numerator, but the dx needs to be replaced, which is 4 cosine theta d theta. So now this becomes 2. This 4 will cancel one of those, and so be 4 to the 3rd coming out, which is 64. So I've taken care of that 4, canceling one of these, and the other 3 came out. And then this cosine will cancel one of those, and I have the antiderivative of 1 over cosine of to the 3rd of theta d theta. which is 1/32 antiderivative of secant to the third theta d theta. Now, I might try some trig, other kinds of substitutions or whatever, but this is where I'm going to pull out the table and show you how to use the table that I gave you that's on your sample test. So in this table, I'm going to move this up here. That's far high enough. Can we see here that we have some, fold this down for a sec. Be patient with me there. I have what are called reduction formulas. If I have sine to some power x times the cosine to some power, if I use this formula, it will reduce the cosine in the integral to 2 lower in degree. Have the same thing, I could also use this formula and it would reduce the sine 2 in degree. So those are reduction of the power formulas. Here I have secant to a power, which I can reduce in this reduction formula. It reduces the power of secant, and this one reduces the power of cosecant. Well, I have secant, and I would like to get it down to a lower power. So I'm going to use formula 13, which is going to be, in this formula, I don't have the 1/32, so I got to include that. And in this formula, m is 3, so I'm going to have the tangent of the, I don't have x's, I have thetas, tangent of theta, secant of 2 less power, so that would be 3 minus 2, which is secant to the first, over the m, which was 3 minus 1 is 2, plus m minus 2, which is 1, over 3 minus 1, which is 2, antiderivative of secant to 2 less, which would be 1, theta d theta. So that's what the reduction formula did for me, but it didn't finish it. So now if I flip this over, I have a formula now for, if I look at the top part of this, how to do secant theta. And we talked about this in class. We've done this one. It was one of the homework problems that talked to you about how to do it. So we get 1/32 tangent of theta secant of theta over 2. I could have brought it out instead of 64. Could have brought that one out, so it could have been 1/64. But I'll leave it in here, or I could put 1/2 times this, but I'll just put it over 2. Plus 1/2 ln absolute value of the secant of theta plus tangent theta plus, and close that, plus c. Now I could put the c inside or outside, doesn't matter. Okay, now let's finish this one up. These are thetas. I need to go back to the x's, so I have to look at my triangle that I made and figure out what each of these are. So we have 1 over, there's a half and a half. I'm going to pull that up, make it 1/64. Tangent of theta, this is the triangle I made. The tangent is x over that. So x over the square root of 16 minus x squared. Secant is hypotenuse over adjacent, so that's 4 over square root of 16 minus x squared. That's tangent times secant, and the 2's out here. Now I have to do plus, and I took the half out, it's in the 64, ln of secant, which is 4 over square root of 16 minus x squared. plus tangent, which is x over 16 minus x squared, square root, and plus a c. And we could get a common denominator, and we could call this part ln of 4 plus x over the square root of 16 minus x squared. And the denominators are two square roots of the same thing multiplied, so it just becomes 16 minus x squared and 4x in the numerator. All this times 1/64 plus c. And that's about as far as we can go. And we could check this by taking the derivative, but I'm not going to. We could also check it by integrating this from, say 1 to 2, and then putting in 1 into this minus 2 into this and see if we get the same answer. Or putting 2 into it minus 1 into it. Okay? So that's a way to check and see if you've done things correctly. All right. Number 3. I'm going to get a clean sheet instead of just turning that one over. Number 3, clean sheet. So this one is the antiderivative of 1 over x squared square root of 25x squared minus 16 dx. And we've already decided this is a secant substitution, which is the middle one up here. So I'm going to slide this up. I'm going to draw my triangle. And so I'm going to use the secant as x over a. Well, x is going to be actually 5x, because that's what that is squared. And my a is going to be 4. And so this side would be the square root of that squared, which is 25x squared, minus 16, which is what I need to have. So we've got that started. Now let's continue on. So this is a secant substitution, and so the secant of theta is hypotenuse over adjacent, so that's 5x over 4. I'm just going to put the 4 over there. I'm going to take the derivative, and I'm going to get 4. Derivative of secant theta is secant theta tangent theta d theta equals 5 dx. So this over 5 is what's going to replace the dx. And then I have to have an expression for this. So I'm going to go to there. So the tangent, opposite over adjacent, the tangent of theta will be the square root of 25x squared minus 16 over 4, which I'm going to put over here. So now we can do some replacements. Well, we've got to do one more thing here, but we're going to have 1. We have an x squared. Well, x squared, that would be 4/5 secant theta is x, if I solve for x, and I have to square that. That's my x squared. My square root is 4 tangent theta. So I've replaced the x squared, the square root. Now I got to replace the dx. And the dx is 4 over 5, if I divide by that 5, secant, this is times, theta tangent theta d theta. Looks like we got a real mess going here, but it's not going to be that bad. Sometimes these get horrible, but this one's not too bad. Notice that the tangents cancel. So we have 4/5 squared, and we have a 4/5 in the numerator, so that 4/5 will cancel one of those, and the other one we can pull out is 1 over 4/5 or 5/4. Oh, and there's another 4 there, so 5 over 4 squared. So I got this 4, and the 4/5 times 4 taken out will be 5 over 4 squared. Antiderivative, and I got secant squared and a secant in the numerator, so that's just one secant left in the denominator. This really looks a whole lot simpler than we thought it was going to be. And see, now what's secant? Well, that's 1 over cosine, so this becomes 5/16 antiderivative of cosine theta d theta, and the antiderivative of cosine of theta is sine of theta. And looking at my picture, the sine is square root of opposite 25x squared minus 16 over hypotenuse. And it looks like the 5's cancel, so I get 1/16 square root of 25x squared minus 16 over x plus c. This one I will take the antiderivative, or take the derivative of it and check it. So the 1/16 will hang around, and I have a quotient. So I take the derivative of the numerator. The derivative of the square root is 1 over 2 square root of 25x squared minus 16. Remember, this is to the 1/2. So if I subtract 1, it becomes -1/2, which puts the square root in the denominator. And I have to multiply by the half that it was to. Times the derivative of the inside, which is 50x. The derivative of the numerator times the denominator minus the derivative of the denominator times the numerator all over the denominator squared. Does that sound familiar for the derivative of a quotient? Derivative of the numerator times the denominator plus the derivative of the denominator times the numerator over the denominator squared. And what times 1/16. And the derivative of the constant is gone. So when it's gone with the constant, we're hoping this comes out to be that fraction. So to get a common denominator, I need to multiply by, let's see, the 2 can go into the 50 and make 25, so I don't have to worry about the 2. All I need to do is multiply this one by square root of 25x squared minus 16 on the numerator and denominator. And so the numerator would just square that. So I'm going to have 25x squared. This squared is going to get rid of the square root, minus 25x squared, and minus a minus 16, which is 16. So I got 1/16 times 16 is 1 over the square root of 25x squared minus 16 over x squared over 1. Which, if I multiply by the reciprocal, I multiply by 1 over x squared and 1 over x squared. The x squareds cancel, and I get 1 over x squared times that square root. And so this worked out. This was simple enough, it was easy enough to do take the derivative and check whether this was really the antiderivative. Okay, so that's 3 of these, and this one we thought was going to be messy and turned out not to be bad. Only difference between these two is that minus changes to plus. But boy, does it make a world of difference. Here we go. So now we have the antiderivative of 1 over x squared square root of 25x squared plus 16 dx. Because it's a plus, we're going to do a triangle like this, which is a tangent substitution. And the tangent's going to be 5x and 4, because the hypotenuse then would be 25x squared plus 16, 4 squared, square root. So the tangent of theta is going to be 5x over 4, which I can put over there. Take the derivative of them, I get 4 secant squared theta d theta equals 5 dx. And the expression for this square root, I'll use this one. So it's going to be the secant of theta is that square root stuff, 25x squared plus 16 over 4, which I'm going to put over here. This looks very familiar to which one we did earlier. Okay, so now we need to start replacing things. So this becomes, there's no constant to pull out, so we just got 1 over x squared. See, that would be 4/5 tangent theta but that would be x, and we have to square it. Then we have this square root, which is this, which is 4 secant theta. That's what that square root is. And the dx is 4 secant squared theta d theta divided by 5. I'll just put it as 1/5 out here. Now let's work with this. Let's see. This 4 and this 4 will cancel. This 4/5 that's squared can come out as, in the denominator, is 16/25, or multiplied by 25 over 16 times the 1/5 that's out there. So I took care of this, that, and that in here, this. The square will cancel one of the secants, so I have secant theta over tangent squared theta, d theta. Okay. Doesn't look very good. So let's change it all to sines and cosines. So the 1/5 will make that a 5/16. Antiderivative, see, secant is 1 over cosine. And tangent is sine over cosine, since it's in the denominator, becomes cosine over sine. And it's squared, so that cosine gets squared and that sine gets squared, d theta. So maybe this won't be so bad after all, because this cosine will cancel one of those cosines, and we'll have 5/16 antiderivative of cosine theta over sine squared theta d theta. And realizing that the derivative of sine is cosine, and it would end underneath the d substitution. If I do a u sub, this might work out really well. Sine theta, then du would equal cosine theta d theta. So if I solve for d theta that I need to replace, or I just look at this, cosine theta d theta, that would be du. This is du, or I can solve for d theta by dividing by cosine theta, put that in du over cosine theta, and the cosines would cancel. But anyway, to have 5/16 antiderivative cosine theta d theta is du, and 1 over u squared, which is 5/16 integral of u to the minus 2 du. So adding 1 and dividing by what we got, see, add 1 would be minus 1, divide by it, so I get minus 1 over u, because it'd be u to the minus 1, which puts it in the denominator, times 5/16 plus c. Now we got to work our way back to x. U was the sine of theta, so it's minus 1 over the sine of theta times 5/16 plus c. And sine of theta would be 5x over that square root, so we get minus 5x over the square root of 25x squared plus 16. That's this, times 5/16. Excuse me. So we got minus, and it's 1 over the sine. And the sine is this over this, so we got to go the other way around. So it's, sorry about that, it's minus, and you probably saw that right away. Square root of 25x squared minus plus 16 over 5x times 5/16. The 5's cancel. So I got minus 1/16 square root of 25x squared plus 16 over x plus c. And that one's easy enough to take the derivative of to check. So we got minus 1/16. The derivative of the numerator is 1 over 2 square root of 25x squared plus 16 times the derivative of the inside times the denominator minus derivative of the denominator times the numerator. Derivative of the denominator times the numerator over the denominator squared. Okay, so once again we have to multiply by square root, get a common denominator. The 2 goes 25, and that's into the 50. And this is 25x squared minus 25x squared. And because I'm going to multiply by, hang on here, 25, getting ahead of myself. So that square is going to cancel the square root, have a common denominator. So I'm going to get minus 1/16 times 25x squared minus 25x squared and minus 16 over the square root of 25x squared plus 16 over x squared over 1. Oh, yeah, the 25x squared's cancel, yep. So if I invert and multiply, I get plus, the 16's cancel, 1 over the square root of 25x squared plus 16 times 1 over x squared, which is what we had to start with. So this one was trig sub, then u sub, and it still took quite a bit of time, space and work to get it. So I will try to make the test, the trig sub, to be a fairly straightforward one for you. Okay, one that doesn't take very much work to get it. Okay. All right, that's my spiel on trig substitution and how to use the tables.